Hi, everyone. Joining me today from Central Pennsylvania is Dr. Bill Bahnfleth, Professor of Architectural Engineering at the Pennsylvania State University and Chair of ASHRAE's Epidemic Task Force. Bill, welcome to Healthy Air.
Yeah, thanks, Eric. Glad to be with you.
Great to have you. I want to share Dr. Bahnfleth's background briefly to provide context for our conversation. William Bahnfleth is a professor in the Department of Architectural Engineering at the Pennsylvania State University, University Park, Pennsylvania. He holds a doctorate in mechanical engineering from the University of Illinois and is a registered professional engineer. He's a fellow of ASHRAE, the American Society of Mechanical Engineers, and the International Society for Indoor Air Quality and Climate. Dr. Bahnfleth is the author or co-author of more than 170 journal articles and 14 book chapters. He served ASHRAE in a variety of capacities, including student branch advisor, chapter governor, technical committee and standing committee chair, director at large, vice president, treasurer, and the 2013-2014 society president. He's a chair of the ASHRAE Epidemic Task Force. His ASHRAE awards include the Exceptional Service Award, the Louise and Bill Holladay Distinguished Fellow Award, and the E.K. Campbell Award of Merit for Teaching, and the F. Paul Anderson Award, ASHRAE's highest individual award. So quite an impressive background. So Bill, to start off, tell us about your origins in the world of architectural engineering, HVAC, and indoor air quality. How did you get started?
Well, it's a story like many probably have. It wasn't what I necessarily expected to do. I have a father who was in the industry and was a mechanical engineer. And when it got time to decide what I would do in college, I was trying to decide between liberal arts and engineering. And I picked what looked like it would be the probably the stronger career and went into it and stayed until I had gotten my PhD and didn't really think about getting into the HVAC side of things until I had already rolled through 2 PhD projects and 2 advisors. And I decided that I really didn't want to do theoretical thermal science work, and that I'd really like to do something in my career that was going to have clear benefits to the public, and something where I could see the results of what I was doing reflected in society around me. And so I shifted to working on a building science problem for my PhD project, and did that with sponsorship from the Corps of Engineers. I was working at the Construction Engineering Research Laboratory in Champaign, Illinois. And from there, I started looking for jobs and didn't look for academia immediately. I didn't really see a good fit in a lot of mechanical engineering departments because HVAC had sort of become the poor stepchild of mechanical engineering in a lot of schools. It's seen as kind of pedestrian, although it's terribly important. And so I actually left the university in the lab, and my first job was working for my father for 5 years full-time as a consulting engineer in Cincinnati. And in 1994, a faculty member at Penn State who had also graduated from the University of Illinois and who was someone who knew my father well because he was the advisee of one of his students, called up. Didn't call me, he called my father and asked him if it would be okay to ask me to apply for an open position at Penn State in architectural engineering. And so I did look into that. I had a lot of trepidation about going into academia at my age. I was 37 years old and had a family, but I got some good advice from my former PhD advisor, and architectural engineering looked like a place where I could do the things I wanted to do, that I could be in an academic position and teach and do research, but research that was really relevant to an applied field. And so that was 27 years ago. And it's on the whole worked out really well. And I have no regrets about that. I didn't get involved in indoor air quality actually until the late 1990s. So for the first part of my career, I was doing research that was mostly carrying on things that came out of my prior energy-focused experience of thermal storage systems, district cooling systems, and that sort of work, and also extending my work on earth-coupled heat transfer modeling from my dissertation. But I had, again, by serendipity, a student come along who couldn't get an advisor, and he had left a career in the nuclear industry doing risk management on the air side in nuclear plants, and he wanted to do something on control of bioaerosols because he had come to be convinced that we were due for terrible pandemics in the future, and that we needed to start doing something about it. And so Wally Kowalski really was the person who got me to start looking at indoor air quality. About the same time, I started seeing articles by Bill Fisk and Olli Seppänen and people who were making this case that indoor air quality is not at the level that it should be, and it's costing us a lot of money and a lot of personal health and productivity consequences. And so that was when the switch flipped, and I've been doing that for 20 years now. Was my main area of research.
Yeah, well, that is kind of prophetic to where we are today. But just so as I went through in your bio, you've been an incredibly prolific author with 170 articles and then multiple books and book chapters. Within the broader field of indoor air quality, which you mentioned you've focused on for the past 20 years, what specific topics and areas have you focused on? And then looking ahead, what areas, what are the frontiers of your research and within the field that you see coming?
Sure. Well, from the very beginning of my active involvement in IAQ, I've been concerned about controls. I'm a building systems guy. I teach HVAC, and I designed HVAC before I came to the university. So what I'm interested in is how can we design HVAC systems to control some of these hazards that we experience indoors, whether it's chemical or particulate or biological. And so a lot of the research has been looking at system level stuff, just how do you design systems overall to be effective and also to be energy efficient and cost effective. But one of the big things that I got into early on, and again, it was because that was something that Kowalski had taken a deep interest in, was germicidal ultraviolet disinfection. So we started working on that, looking at systems installed in air handling units back in the late 1990s, and I think got to be known as one of the places that was doing the most on those airstream disinfection systems. We got some good grants in the first decade of the 21st century, and built a nice lab that had an ASHRAE 52.2 rig in it that we could do bioaerosol tests in, and did some interesting stuff on the effective operating conditions on the output of germicidal lamps, developed some of the first modeling software for predicting dose in those devices. And then we moved on from that to looking at procedures for determining the UV susceptibility of different microorganisms. We were at the time just looking at some typical test bacteria in our rig because they were easy to use. Our lab was a BSL-1 lab, but interestingly, a reactor that we built back in those days during the PhD work of Steve Martin, who's now at NIOSH, was something that we pulled up to do testing on SARS-CoV-2 and another coronavirus a year ago. So that stuff is still useful for assessing the effect of UV on different pathogens. So that right now is still my strongest interest is UV, but I'm branching out more into other types of air cleaners. I think the last year has shown that there's a lot to know about how different kinds of so-called electronic air cleaners or additive air cleaners, reactive oxygen species air cleaners work. and how to apply them. And so I think that's an area that many people should be working in, and I'm starting to get into that a little bit myself now on the component side. So one piece has been air cleaners, and the other has really been looking at how you put together a whole system in the building. And I should say that my early interest in IAQ was kind of boosted by 9/11, and not the 9/11 that brought down the Twin Towers, but the anthrax mailings that were, probably entirely unrelated that happened shortly after. As that created a huge surge of interest in protecting occupants of buildings from both chemical and biological contaminants. And we did a lot of research that, from my point of view, was just indoor air quality research, but it was really funded out of concern about future terrorist attacks on buildings. And so that started us along a path that continues to be fruitful today, because we're trying to answer the same questions. And of course, the depressing thing about that story is that 15 years ago, millions and millions, tens of millions, who knows, hundreds of millions of dollars were spent on figuring out how to protect people from airborne biological weapons in buildings. And what we did with all of that information was basically nothing, because the result of the risk assessment was that, well, it's so unlikely to happen in any given building that we just don't need to do anything. And so 20 years later, when COVID-19 came along, we had the same kind of buildings we had back then, and we're seeing what happens when you have a severe biological aerosol threat in the building, and they're designed the way we've been designing them for many decades.
All right, great answer and overview. Since last March, you've been chairing ASHRAE's Epidemic Task Force. It would be great to get a sense of how that task force was stood up and how you became the chair of it, and then what has it been up to during the pandemic, because it certainly has had its challenge, or it's had a major challenge on its hands, and very interested to hear about the kind of the work of the task force, and currently what are you up to?
Yeah, sure. As far as its genesis, it took a little while for organizations and really the public to realize that COVID, this is a real thing and it's going to be bad. The index case, I think, was maybe in December of 2019. And when I went to the ASHRAE winter meeting in late January, early February of 2020, we were just starting to talk about it. There were a few Chinese companies that had pulled out of the HVAC&R show. They couldn't get there, and a few people that you'd expect to come who didn't come because things were starting to get bad elsewhere. But at that time, there were maybe only a few thousand deaths, and that was back when we didn't want a cruise ship to dock at a U.S. port because that would add so many cases to the caseload. But so between then and March, things just really took off. And so sometime between that ASHRAE meeting and about a month later, the leadership of ASHRAE realized that they were going to need to make a response. They were being called on by many to make a response. What should we do to make our buildings safer? So they sent a list of questions to the Environmental Health Committee. And I was a member of the Environmental Health Committee at that time. I still am. And it was really starting with, should we have a formal body to deal with the pandemic, and a number of questions about how it should operate. And so we as a committee responded to all of those and said, yeah, we should do this. And by whatever path that I can't quite remember, I wound up being put forward as a person to chair it. And it was really a unique opportunity because maybe it was because of the presidential aura or something, or just the wisdom of the leadership of ASHRAE, maybe a little of both. They basically said, well, tell us what we need to do. So it was kind of up to me to propose a name for it. I proposed Epidemic Task Force instead of COVID-19 Task Force, because I saw this as something where if we did it right, we would be addressing not just what happened during the pandemic, but what happens after it. And I knew that one of the priorities was speed, that we needed to get guidance out as quickly as possible. And that's not exactly something that ASHRAE is known for. You know, we have an addendum to Standard 62.1 that's been circulating for 4 years now to modify the indoor air quality procedure. So question is, how do we work within ASHRAE to get something important done much faster than ASHRAE usually does it? And so they let me pick the people I wanted to be on the task force. I kept it a relatively small group, and I decided that we weren't going to just take in hundreds of members, but we would make these individual members of the task force proper a steering committee, and each of them would have their own little kingdom to run. And I said, you go find whoever you need to address your issue, commercial building guidance, building readiness or commissioning guidance, filtration and air cleaning. You get them together and put together guidance as well and as rapidly as you can so we can get it out. And so that wound up being an effort with over 130 people who were involved in the teams. And we probably have 15 or 20 liaisons from other organizations that sit in on our meetings too. So that was their method of working. We would meet about every 2 weeks for 2 hours as a task force at the beginning. That's tapered off a bit now for reasons I'll get into. But we were really working hard, and it was for a lot of people 7-day-a-week part-time job. The other thing that I told the members of the steering committee was we're not going to sit here in a vacuum and make ASHRAE's guidance. We've got 100 technical committees, 100 standards committee. There are lots of subject matter experts in the society who have something to say about this and want to work with them. So the other charge to them was to network as effectively as they could with those other committees so that we were doing things really on behalf of them, not apart from them. And all of that has worked pretty well. We started getting guidance out within a month, I think, the earliest, and had a pretty complete set of initial documents out by summer. But of course, that meant that our initial guidance was pretty much whatever we could pull up quickly, and we didn't have time to do a lot of research, and it was pretty extreme, very conservative. So in laying out what's the arc of our committee's existence, the first piece was to get something out fast. The second piece was to refine it and fix it and continue to update it based on what we learned. Then the third part was to make this bridge to the future. How are we going to carry forward this work, which is going to take many years once we sunset the task force, which I hope happens at the end of this year. So I don't know if I've left anything out there, but that's kind of how we got started. And as you know, we managed to produce something like 400 pages of guidance in a matter of a few months, much faster than normal process. And it's been so successful that ASHRAE has come to us to kind of study what we did and try to figure out if it can be bottled and used in other similar urgent efforts. There's now a decarbonization task force, which is addressing another urgent issue, which is the problem of climate change.
It's really, really impressive on that. So the task force is confronting a risk that is novel, it's fast moving and dynamic. And even today, a year and a half plus into the COVID-19 experience, not clearly completely understood. In some areas, it's still major questions that are open. How is the committee or the task force operated with a risk like that? And how is it been adaptive to the changing conditions on the ground, which are happening all the time?
Sure. Well, I think you have to start from the position of realizing that we don't know everything that we would need to know to come up with a perfect answer, and we're not going to know it, and that there are other disciplines outside of ours that have things to contribute. And when you start putting out guidance, you have to be very clear about what you know and what you don't know, and how accurately risk has been assessed, and how strictly anything that you're recommending needs to be followed. And as I think you and I both know, our ability to estimate the actual risk of infection from COVID-19 is pretty limited. We have some good ideas about relative risk from a fairly small amount of data. And so we have to just say that, but we're always looking for confirmation that what we're recommending makes sense. And while we haven't been able to come up with, let's say, uncontaminated air delivery rates, clean air delivery rates specific to COVID for a lot of different occupancies, like you would find in ASHRAE Standard 62.1. We've looked at a lot of research, and we also have healthcare indoor air quality to compare to. So I'm not entirely happy saying that 4 to 6 air changes per hour has been calculated as a reasonable target. But on the other hand, if I look at a healthcare standard like ASHRAE Standard 170, 6 air changes per hour is getting into the area where that standard is specifying ventilation and filtration. So, we've adjusted some things as we go along, but in a strange way, we've been waiting for the public health authorities to catch up to our outrageous contention early on that airborne transmission was important enough that we should do something about it. I mean, that was one of the things that I'm really proud of, is that both REVA and ASHRAE in March and April of last year, respectively, said, we may not know for sure whether this disease is airborne transmission, but we have enough evidence that it might be, that we ought to apply the precautionary principle, which is something that comes from medicine, and take reasonable actions to reduce the risk of airborne transmission. And it's taken almost a year to get to the point where WHO and CDC now have statements that are essentially in agreement with that. And I know that they have a process and they look at data in a certain way, but I think that we were absolutely right to take the position that if we could afford to protect against that particular risk factor, it was worth doing, and it seems to have been the right call. Other things that have changed in terms of understanding of the disease, not too many things. We have supported from the outset wearing masks and distancing and other public health guidance. I'd say what's changed the most has been our view of how to approach designing controls. So as I said, we started out with really extreme recommendations like increase the outdoor air in your system as much as you possibly can, or run your HVAC system 24/7 to make sure that the building is as clear as it can be of contaminants, and turn off energy recovery ventilators because they might be allowing reentry of contaminated air. So all of those things have negative impacts in terms of energy and in terms of indoor environmental control and maybe even equipment cost. I'd say the main thing that we've done is to develop an approach that moves away from that and has provided those who are trying to design controls to do it in a much more flexible way. So increase outdoor air if it's something that you think is a good way to increase protection, but we're only saying you should have at least what the code requires because we have to have basic indoor air quality in buildings. Increase your filters to MERV 13 if you can, but if you can't, there are other ways to bring the level of the system up to that point, and combine controls to minimize energy use and cost while meeting your risk reduction target. Of course, that statement ends right where our knowledge sort of trails off, and that's where the unanswered question, or not fully answered question, is what is an appropriate risk reduction target. It's not just that if we have a goal, we can calculate what the clean air delivery rate should be. We have a lot of disagreements in different parties about what acceptable risk is, and that's one reason we've kind of stayed clear of it, but we've mapped out how you would do these controls once you've decided what your acceptable risk is.
So picking up on some of what you just said, so the nature of this risk, this health and safety risk, is touching multiple disciplines and professional domains. So you've got infectious disease and public health and medicine. You've got mechanical HVAC systems. You've got environmental health, safety consulting, and industrial hygiene. How well do you think the different disciplines and professional domains have coordinated with each other to address the risk at hand and to really have coherence when you're getting out to the real world to provide guidance and to get things under control?
Yeah, well, I think primarily from my perspective, that's been a pretty positive story over the course of the pandemic. I've had the opportunity, and others in the task force have had lots of opportunity to interact with many other disciplines that are supposed to being help solve this problem. I could have pulled out the ASHRAE infectious aerosols position document a year or two ago, and it would give me a list of all the parties that should be involved in coming up with a good risk management plan. But most people who read that had never put together a team like that or interacted with them. And I think that there's been a lot of reaching out across disciplinary lines to try to understand each other's point of view and to come up with good solutions. I've done presentations for the Federal Facilities Commission. I've done presentations for NIEHS a couple of times. I have talked to an industrial hygiene group, and I did grand rounds for occupational health and safety at the Rutgers Medical School. So there's been an amazing amount of breaking down of silos and sharing of knowledge during the pandemic that I hope will continue after it's over.
Today, do you think we have a consensus view across disciplines regarding what constitutes safe, quote, safe for a building or a facility from a COVID-19 and airborne disease perspective?
Oh, I wouldn't say that we have, everyone is seeing it the same way yet. And don't forget that one of the unique things about the pandemic is it's been such a major event that the public is maybe at the level of being a discipline now too. You not only have to talk to the other disciplines, you have to talk to the public pretty much on a daily basis. And so no, there are different perspectives on what is acceptable risk. What one person thinks is being overly conservative because perhaps we're looking at what would it take to protect each individual in this room if there was an infector there. The others who say, well, what are the chances of an infector being in the room? There's only 3%, 5% incidence of disease. We should be looking at limiting the number of infections community-wide to a point that will cause the epidemic to die out. And so those sorts of of debates, I think, are ongoing, and it'll be really interesting to see where policy and standards making organizations come down after this is all over, and then they've had time to work through a consensus process to determine what we should do, if anything.
Yeah, and on that point, so ASHRAE Standard 62.1, ventilation for acceptable indoor air quality, is the IAQ Bible and reference standard for building engineers, but it was not developed for infection control. You've been very clear on that. But meanwhile, many have argued that we need a quantifiable standard for IAQ as it relates to infection control. So what form should this take? If we had a standard for IAQ as it relates to infection control, in terms of what that would look like, would that be expanded scope of 62.1, a new ASHRAE standard, or should it be something that goes outside of ASHRAE and it's kind of out of scope for ASHRAE standards?
Yeah, well, there are many possible futures for that. If we just use 62.1 as an example, the main problem with it right now is that it has a definition of acceptable indoor air quality that doesn't include infection control. It's control of typically building and occupant generated contaminants other than infectious aerosols, and subjective satisfaction with air quality. And the one thing we know for sure is that that's not the level of IAQ control that it takes to significantly reduce risk of a highly transmissible airborne infectious disease. So if we simply change the definition, that's a good starting point to include ventilation for infection prevention, maybe when necessary. That could be one way to do it. So right now, the ASHRAE strategic plan is emphasizing indoor environmental quality and resilience. I see the ability for a building to adapt to something like an epidemic disease as resilience, in the same way that the ability of, say, a building in the Pacific Northwest or Australia to adapt to a wildfire is resilience. You don't want to operate in that mode all the time, but you'd like to have the flexibility to provide more protection when it's needed. So that's one possible pathway, is that 62.1 takes on a change in maybe its scope to not only look at ventilation for normal operation, but to address requirements for what used to be called extraordinary incidents, or for cases where resilience is required. If that doesn't seem like it has legs, then the alternative might be to go outside of that and develop something like a guideline that would address resilience, something that would address how to enhance basic building design, building beyond 62.1, if you were concerned about those sorts of things. Guidelines have a lot more latitude to pull in information from various sources and recommend best practices. The minimum standards like 62.1 really get locked up with a lot of competing interests. Some are economic interests, and some are social interests, and you may not be able to go so far. But so that's ASHRAE. But what would really be helpful, because this is something that a lot of ASHRAE members who work on committees want, is for bodies that are authoritative outside of our field to provide us with the information that we need to have. So we don't have really from WHO right now very strong recommendations about what equivalent ventilation rate should be. We've got 10 liters per second per person for non-healthcare facilities, which works out to about 3 air changes per hour, is 21.2 CFM per person, while they're still recommending 60 liters per second per person for healthcare facilities, and that they tend to shoot for the minimum that can be widely applied to differing levels of economic development. So I think that's probably too low. But if authorities who deal with disease transmission and health could provide us with criteria we could use, then I think it's fairly straightforward to incorporate them in standards. Right now, there's a lot of concern amongst some in the engineering community that they would be responsible for making buildings safe and making them healthy. Well, my point of view is, well, we're dealing with contaminants that affect health in buildings now, but the reason we don't worry about it is someone has established a standard of care that we can point to, say, occupational exposure limits, for example, for chemicals and for particulate matter. So a lot of things could happen. That's how I would mainly see it playing out. And I suppose I should also say that air quality standards are not the only things that are going to have to change. And we have to do something that I think is really difficult because of the way the standards process is set up, and that's to get good interaction between air quality and energy efficiency, sustainability. So, really there needs to be some either explicit or informal coordination between a standard like 90.1 and 62.1 to figure out the ways to upgrade air quality to have it where we'd like to be, not just for disease prevention or wildfires, but also just to improve the ability of buildings to support health and productivity without damaging our efforts to decarbonize and to get to net zero for buildings.
Mm-hmm. So in May, you co-authored an excellent piece, I will say, in Science, along with a number of other very prominent scientists and engineers, titled "A Paradigm Shift to Combat Indoor Respiratory Infection. Building ventilation systems must get much better." At a big picture level, what do you see as the problem that we're facing right now with respiratory infections and ventilation? And what do we need to do about it? What is, at a strategic level, the path forward to help attack this problem?
I'm really happy to be a co-author of that article, even though, of course, when you write a paper with 39 other people, it's really hard to agree that everything in it is exactly the way you would want it to be. But I think there's a lot that's right here. And I think the first thing is this article is just trying to lift the scales from people's eyes to see that we can actually do something about the risk of disease transmission in buildings. So we would kind of go back to what I was discussing with respect to standards. We could start simply by saying we can do something about it. It's called a tractable problem in this article. So simply agreeing that if we wanted to, we could reduce the risk of respiratory disease infections in buildings is the place to start. And once that commitment has been made, then I think all of the science and technology apparatus that we've been talking about here can get to work on solving the problem. And I think that one really interesting aspect of this article is how practical it is in a way, given that I may have been the only registered engineer who was an author. There were all sorts of people there from many different disciplines, but it really addresses the need to be sustainable and talks about reinventing demand-controlled ventilation so that we can provide healthier conditions where people are present without hurting energy consumption of buildings. And I think another important thing here is that it points to the need for investment in better risk assessment of infection transmission so that we can develop new standards and policies. That's, as we've been discussing at length, one of the things that's been clear during the pandemic is that we don't really know enough yet maybe to set long-term standards for what we should be trying to do in buildings. But we've been able to do it in other areas with respect to other indoor air contaminants. WHO has published health-focused exposure limits for other air contaminants. So I believe it's doable for infection risk as well. Of course, the paper leads off by comparing air quality to water safety and sanitation, and some have said, well, it's not really the same thing. But I think it's still a useful analogy that we've just developed a high tolerance for getting sick in buildings and tending to act like there's nothing we can do about it. I think one of the best bits of evidence that that's mistaken is that there was basically no flu season last year. So whatever we were doing to try to tamp down COVID-19 also seems to have shut down a whole flu season. And that really puts this in a different perspective. If it's not just dealing with a 100-year pandemic when it comes around, but tens of billions of dollars of healthcare costs every year and many thousands of deaths from seasonal influenza, it starts to look like something that would be economically viable. And that's another point that's made in the paper, is that there's a lot of good evidence if you read the background that the cost of making buildings lower in risk of infection transmission would pay for itself in the various benefits that would accrue as a result.
So do you believe both at a kind of general public level and then also political level too, that there's sufficient awareness of this problem that we have that you just outlined regarding the airborne disease kind of risk levels in buildings and the importance of ventilation? Is there awareness? And then relatedly, is there will and commitment that you see to advance the types of reforms and investments that you're proposing in the article? And I guess said a little bit differently, there are concerns amongst people in your field and people touching the ventilation airborne disease issue of the window is open now because we're going through such a terrible experience with the pandemic. But if we get things under control, then there's going to be a lot less urgency and pressure, and we may miss the opportunity to really advance forward a lot of the things you're proposing that obviously extend beyond COVID-19 to a broader public health issue that we will be facing again in the future.
Yeah, well, as far as awareness goes, I think there may be more awareness than there has been at any time during my professional life. It's hard to imagine when anyone has been more aware of the risk of infectious diseases and of the damage that they can cause to society and the disruption of life. I'm not sure that the awareness is at the level I'd like it to be yet, and also particularly at the level of awareness of the role buildings play. I think it's great that in the U.S. we're now, I think, doing more to try to end the pandemic, but I still hear a lot more discussion about vaccines and masks than I do about HVAC. And vaccines are always the easy out. Oh, a disease comes along, we'll get a vaccine, and then we won't have to do anything. And maybe that's what helped get us to where we are, is the belief that there are vaccines for things, and then that's better than spending a lot of money on making buildings better. I think there's a lot of public sentiment in favor of improving our baseline standards of indoor air quality, but of course that's kind of polarized too. But I do think that public awareness is an important thing. This will test one of the things I've been saying in my talks for many years. I give an ASHRAE distinguished lecturer talk on energy efficiency and indoor air quality and how to integrate them. And one of the things I point out at the beginning is that if you're going to really get something done in a big way, it's sort of a three-legged the stool that you have to put together. You have to have a scientific case, and you have to have strong public interest. And if that happens, then maybe government will get involved too. And when you have all of those on board, then things will happen. And I think that's been behind the progress that we've made, which has been pretty impressive, really, in energy efficiency and outdoor air quality over decades, although there are always things to have regrets about there. But when you compare that with where we've moved in indoor air quality over the comparable period, let's say from going back to the 1970s, not much has happened. So what I think is really important is that that we develop the resolve to go forward now and do something about it. And I think right now it's a coin toss as to what will happen. Again, going back to my experience after 9/11 and all of the things that we talked about doing that we didn't do. But I think now is really the time to raise the bar on air quality, or there may not be much hope of doing it for a long time.
So beyond your work in academia and ASHRAE, you do quite a bit of work in industry, advising practitioners, startups, people who are out in real buildings. What are your experiences and observations regarding how well the real world businesses and public entities are responding to the health and safety challenges that we're dealing with today, and how well the types of guidance and guidelines that you're putting forth with ASHRAE and otherwise are actually being adopted out in the real world?
Sure. Well, of course, those interactions that I have, things that I may do as consulting activities or as pro bono kind of work has generally been trying to help people who want to be helped, right? So a consulting firm may ask me to work with them on developing concepts for COVID mitigation, or closer to home, a local school called me up and asked me to come in and review what they were doing and give them advice. So there are many out there who are really trying to do the right thing and to find out what they should do. We've also worked with some agencies that were looking for that kind of help. So I feel positive about that there is a lot of interest in improving things and awareness that things ought to change. But I've also talked to more people than I care to, who are always looking for reasons to believe that none of this stuff really helps very much, or that's not necessary. And that, when we get into the issue of changing standards in the future, is the kind of thing that's going to come up. So there's some naysayers out there that say, well, we may be doing stuff, but it's not really helping. But I think the evidence is there that it does. So all of that has been a good experience. Manufacturers, I think, are a group that I haven't worked with too much, but I think they're really important because they've got to get on board with this idea that we need better standards that we have, and that we have to be really transparent about how different technologies work, and to be able to certify products so people really know what they're getting. That's been a big frustration, because for me, I think that air cleaning technologies ought to be a really important piece in having better IAQ and also using less energy. But until we get equipment that we can say really works in application and is safe, it's hard to do that. And I feel there are technologies out there that probably are just fine, but I can't really recommend them given the lack of these kinds of certifications. You wouldn't buy a chiller that wasn't AHRI certified for its capacity. Why would you put something that potentially has health effects in a building if you don't really have independent demonstration that it's safe and effective.
Mm, mm. So you mentioned earlier that you do a lot of work not only on indoor air quality from a health and safety perspective, but also energy efficiency and climate and sustainability. How are you thinking about the key trade-offs, and then what is going to be important in terms of how we balance those two sets of concerns and issues in terms of practice and the need for flexibility or compromising on those? Like just at a high level, how are you thinking about given how urgent both of those? Although the pandemic seems more urgent right now, there are many critical sustainability type of goals that are coming up in 2025. And then as we're seeing, climate change is real right now. So how are you thinking about kind of balancing these two major imperatives within a building to come together in a way that actually, translates where you're addressing both simultaneously?
Sure. Well, of course, one important thing on the IAQ side is to figure out what's really important and not overshoot in terms of making buildings better. So we want to have a level of IAQ in buildings that is really going to get a large chunk of the benefits that we believe are there. And actually getting benefits really means reducing the penalties of not having good air quality. So that's one thing that we need to understand well. And then I think it's a matter of putting our creativity to work to develop ways to manage indoor air contaminants that is going to be as energy efficient as possible. And of course, I mentioned demand-controlled ventilation before. Everyone knows that just like source control, the best way to save energy is to shut something off. So I really think there's a role for sensors and building management systems to do a better job of determining where people are in buildings and what they need in terms of air quality control based on sensing key contaminants. And if you can do that, you can set back lots of other areas and probably have lower energy use than we have today, but still higher indoor air quality where it's actually needed. And we have proof that the need for that is there because we've seen that in New York City, for example, the energy use of office buildings when they were at 10% occupancy was not much lower than it was when they were fully occupied. So those buildings, even with a few people in them and without advanced IAQ controls in them, were wasting a huge amount of energy. So I do think that DCV is going to be a big part of it, smart building technology, and also that being supported by air cleaners. So that was the other thing that I already mentioned. I think we have to look for alternatives to ventilation. How much ventilation do we really need to be safe from the things that we don't know are there very accurately? The thousands of potential contaminants in the air. And one of the good things about ventilation is it doesn't really care what's there. It will dilute and displace some of it. So when we start using air cleaners, we have to get very specific about what we're controlling over and above that. So the maximizing of using those kinds of technologies is important. And then when we ventilate as efficiently as possible. And that brings in issues like air distribution. Should we bite the bullet on really doing a lot of personal ventilation in office buildings instead of having general ventilation? Should we be really focusing on better air distribution to move contaminants in the right direction, more stratified air distribution systems? And that's all before you get to how much outdoor area you should have. And then whatever we bring in, we should bring it in as efficiently as possible. And that gets into energy recovery, which is becoming more and more common, and the requirements for energy recovery and standards like 90.1 keep going up. So there are a lot of things that we can do. And maybe one more to mention is, how about if we agreed that we are going to regularly maintain buildings so that they function the way they're supposed to? I've grown up as an energy engineer being told that there's evidence that if building controls were commissioned, that we could save on average 15% of the energy use of a building. That 15%, if it's real, will pay for a lot of upgrades in air quality. I don't think we should have to have a penalty for improving air quality, but there is that potential savings there that would pay additional dividends. So it's not magic or rocket science. We've known for a long time the things that could help, but we have to agree that we're going to try to make them actually work in practice.
Well, fantastic discussion. I want to give you the floor for any parting thoughts before we end here.
Well, we seem to have covered just about everything, so I don't have a big concluding speech to make, but I think maybe the thought I'd like to leave people with is that, this is a really bad time we're going through, but it's had some good consequences in terms of bringing people together and stimulating scientific and technical inquiry that's going to be useful in the future. And let's not waste the crisis, as Churchill said. We're going to come out of this, and we're going to have an opportunity to make sure this doesn't happen again, at least to this extent. And I hope that everyone will keep reminding themselves that it's important to follow through and finish this job that we're just starting now.
Great parting thought. Thank you so much for coming on. We recognize what a busy guy you are. Really appreciate you taking the time, sharing your perspective, and for everything that you're doing.
My pleasure, Eric. Glad to be with you.